Genetic diseases are often caused by changes to a gene that may disrupt the structure of a protein or its function. These changes, or mutations, may be due to errors that can occur among the 4 bases, represented by the letters A, C, G, and T, that spell out the genetic information carried in DNA. A disease-causing mutation may also result from a single spelling error known as a point mutation. Point mutations occur naturally and frequently, but occasionally they can cause a genetic disease. The diseases caused by them are rare. However, these diseases total in the thousands. Now, for the first time, there may be a way to edit a single base, potentially curing genetic diseases at the root cause. Beam's vision is to create lifelong cures for patients suffering from serious diseases. So we are part of an amazing revolution in medicine. We want to create therapies that can be dosed once or a few times to patients who have very serious illnesses and give them a potentially lifelong benefit. When we started Beam, we had this very powerful technology that we knew could treat a lot of different diseases. And we made an important decision early that we wouldn't just focus on one disease area or one type of indication, that we needed to go broad. And the reason is because we really felt a moral obligation to bring this technology to as many patients as possible.
I've always been convinced that gene editing was going to be part of the medicine of the future. This first generation of gene editing technologies were based on nucleases, which basically make a double-stranded break into the DNA. And even though it does lead to knocking out of the expression of the gene, unfortunately it's not very controllable. And instead what base editing had done was directly making that change that we wanted from one base to another.
So to understand a base editor, you really need to understand DNA. DNA is the genetic code that is the instructions for all your proteins and things that go on in your body to create life. These instructions are composed of 4 letters, A's, C's, G's, and T's, which are chemical compounds. And every once in a while, there's a misspelling. A base editor consists of 2 main components: a CRISPR-Cas9 protein and a deaminase. The CRISPR-Cas9 protein is bound to an RNA guide that precisely targets a specific base. A deaminase enzyme then carries out the desired chemical modification of a single DNA base. During base editing, just one of the 2 DNA strands is chemically modified. The edit may be more efficient when the opposite strand of DNA is nicked. The nicking technique tricks the cell into using the freshly base-edited strand during DNA replication, making the edit permanent.
Beam was founded to create a next-generation version of gene editing called base editing, which is even more precise than some of the previous tools. And we think that it could be very important and impactful for patients with a wide range of different diseases.
Base editing really has the potential to possibly cure genetic diseases. And this is the first time that this can happen in human history. And that's really powerful because no longer are we treating the symptoms of a disease, we're actually potentially curing that disease.
From the beginning, the vision at Beam has been we would like to have under one roof all the different components needed to create the right medicines for patients at the right time. And that means 3 things. First, it means having right editing. So base editing, of course, is the lead of what we do. We actually have other editing systems as well, and we're constantly trying to improve on those and innovate and create new ways to do gene editing better for patients.
Basically, the analogy that we typically use is the first generation of editing are more like scissors. They get to a point in the genome and basically they cut it. What you can think of base editing is more like a pencil. So you're able to land on a piece of sequence, you have an eraser that basically deletes the mistake or the unwanted sequence, and you simply rewrite it in the one that you want. It's a simple technology in a way, but it's elegant because of that.
I was also incredibly impressed by the underlying technology of the company. It was the first time that I felt like some technology was so intuitive, and that for the first time we actually had technology that could potentially cure the underlying genetic conditions or genetic mutations. It was elegant, it was simple, and the passion and enthusiasm around that was infectious.
When most people think of base editing, they think about its ability to directly correct disease-causing point mutations, which are the result of a single spelling error in a person's DNA. Additionally, base editing can be used to therapeutically intervene in a number of ways. For example, it can be used to create protective genetic variations in genes, activate gene expression, silence gene expression, or even make multiple simultaneous edits called multiplex editing. We believe that it's possible that through this more precise editing of just erasing one base and not cutting the double strand of DNA, that we may be able to mitigate from having some of these unintended consequences of gene editing. Of course, this will take time and long-term follow-up to actually demonstrate this, and this is something that we will be following closely.
So nothing matters unless we can get these editing systems to the right cells at the right times for patients. We are basically doing all the different kinds of delivery that are possible in genetic medicine. That means taking cells out of the body, things like blood cells or immune cells, editing them and then putting them back in. It means using non-viral vectors like lipid nanoparticles to take the editor into the body, something like targeting the liver, and then edit those cells in the body. Or using viral vectors like AAV to target organs like the eye. These are all critical and diverse ways of delivering these medicines to patients. The third piece is manufacturing. So nothing matters unless we can make these medicines and these delivery constructs with high quality and very reliably. And so we are also building internal manufacturing capabilities to be able to do this as well. Ultimately, our goal is to always have under one roof Beam's own proprietary technologies to create medicines for patients. Whenever we see a new patient, a new kind of biology needs to be targeted, we have the tools to do it using these editing technologies.
I think it's important that we take scientific discoveries and get them to patients in as safe and as expeditious manner as we can. We really have a culture that is fearless in its innovation. And so what that means is we're not afraid to push the envelope. I think when you're developing a drug, you have to think about your destination. Our destination is really to provide meaningful and potential cures to patients who suffer from serious illness. That's our goal.
One of the most important technologies of the 21st century is going to be gene editing. We have the ability to rewrite the code of life and change outcomes of genetics. The ability to bring that kind of power to people and families who are suffering and potentially make a difference is an incredible responsibility and privilege. And I like to remind people of just what an exciting moment in time we are at. I think this century is going to see profound changes in medicine and biology, and Beam and these technologies is going to be a big part of shaping that. And I'm just incredibly excited about the journey ahead.
We really want to think about trying to treat diseases at their root cause, and that's what we're perched at right now, this exciting opportunity to show for the first time that base editing, in fact, works in man. We're ready to start to gather data through clinical trials in humans, and that's exciting.
It is like a dream come true. If you think that this was a technology that didn't even exist until 2016, and within just a few years, we are now able not only to go into patient study, but because of the technology, we have the potential to actually cure the very first patient that would receive this base editor.
But I also think that it's important that we leave the scientific community better than we found it. And so to the degree that we aren't always successful, if we've improved the knowledge about what the patient experience or the underlying causes of a disease, then we've actually helped make strides on behalf of patients, I think we would have actually been successful.
We feel a profound sense of responsibility with our mission at Beam. There are patients out there in the world today who are desperately in need of new options to treat their disease, which has changed their lives, changed their families' lives, and they are waiting for better cures. We believe that these technologies have the potential to be that for many of those patients. So that fuels us and pushes us to try to bring this technology as quickly as we can, but also responsibly forward as a potential new class of medicines for patients with a wide range of diseases.
I think there are lots of things that make Beam special. Among them is the fact that we are a community and that we focus on building that community, building a culture, harnessing that culture so that we are constantly pulling in the right direction or in the same direction. And I always remember watching the rowers on the Charles River. And what is so beautiful about watching those is you're just seeing everybody in sync. And you realize that when one person is off, it throws the balance off. And that's always the image that I think about when I think about beam. It's that gliding on the water and pulling in the right direction. It's not about what I individually can do. It's whether or not we collectively can actually do something on behalf of patients. And that's what drives everything.